Right, good afternoon, gents. Take a seat, please. So, guys, those guys that are handing stuff in digitally, you will see a I don't even know where to look. When you see this, put it in the class notebook under your name. Okay, so you'll find it. Right. So, guys, I wanted to say a couple of things. Maybe just sit. We're not sitting. Okay. Thank you. Yeah, someone's gone off to fetch his work. Resi's gone off to fetch his work. Who did you say is not here? Obviously, I know about Nick Smithers. Carlton. Okay, so unit.
Wait, is this a handout or a homework? Hold on.
Homework. Hewlett, Smithers, Butcher. Where's Butcher? Oh, did you? Yeah. And anything else, Charlton? Say.
They want to know it's a PDF. Yeah. Put that in.
So I'm still missing one other. But, yeah, this is far from ideal, but I'm recording. Yeah. Green, blue, green. Yeah. Right. So being a little bit stressed about them, which is like not really what I want. Okay. But I also do think that one needs to sort of be prepared to dig deep, okay, and to kind of engage and to think about it and to kind of put in the time. So for the lessons this week, yesterday and the day before, I actually made videos for Nick, and I'm recording this as well. So it gives you every opportunity to sort of go back and look over it. Okay. I also sent you an email that I sent to your parents. In that email, I said that I'm not taking any irresponsible risks with your education. In other words, I'm not going to make sure that we do okay in further studies maths and we all like dip out in the core maths block test. It's not going to happen. Okay. You guys are bright enough to manage both these things. The further studies, we've probably done the hardest stuff in it, to be quite honest. Okay. A lot of it's quite formulaic, and quite a lot of it, whether you understand it fully or not, you can still do it, and you can do well in it. So don't stress about it. You'll see it will be okay. You've got to have a level of trust here. But equally, don't think, well, I don't need to do any core maths. Like I'm gonna I'll just remember how to do that. You need to practice it. Okay. The next week, okay. So come starting on Monday, we've got a double first up, not consecutive, but lesson 1 and lesson 3. We're going to work on core maths. Okay. Right. And we're going to kind of go through a whole lot of the core maths. But just in case anyone wants to look at some core maths this weekend, the next kind of little topic is when you've got a square root in an equation. And what you do when you've got a square root in an equation, you square both sides, but it won't help to square both sides right now. What you've got to first do is isolate the square root. Okay. So root 6 plus x equals x, and then what you do is you square both sides. This one's particularly straightforward because squaring x is just x squared. One like this, thank you. One like this, when you square x plus 1, guys, square it properly, right? X squared plus 2x plus 1. And also, don't forget you've got to square the 4, so that'll become 16. Whenever you square both sides of an equation, you potentially introduce an extra solution. Have a look at this. What is the solution to this equation? Very, very straightforward. What are the possible solutions to this equation? It's two to the yes. Anything up to the negative 4 is now an option. Yeah, now you get a negative 3, and you square that, you get a 9. So when you square both sides of an equation, there's a risk that you've introduced an extra solution. So if you look at this, guys, these are my notes. This little picture there, check. Square root, check. When you see a square root, check. Okay. I want us to sort of just close out the topic that we're busy with at the moment on further studies. So we can make sure you've got that in front of you. Now, guys, listen to this. Okay. And I think it's quite hectic. It says, suppose you are to draw n marbles from an urn, little n, from an urn containing big N, P of which are white, right? Then the formula is given as follows for how many white marbles you will get. Okay. All right. So if you look at it, you want R white marbles out of P. The balance of the total number of marbles, big N, minus P, must be non-white marbles. Okay. And then remember, if you add the tops, you add the bottoms. This formula gets given in exams. Okay. But to be honest, it's a bizarrely unhelpful formula. Actually, it's got all these P's and N's and big N's and little N's and R's. All we need to be able to do is answer the question. So let's try this one now. Example 3. You've got a little urn or a little bag, whatever it is, with 5 black, 10 white, and 15 red. Okay. Now what we do is we take 6 out. And again, I'll just emphasize that's either 1, 2, 3, or put your hand in, grab 6, make sure feel you've got 6 and take 6 out. Okay. What's the probability that you pick exactly 2 of each color? Now, we were doing this yesterday, so I'm hoping you guys are up for it and back with it. Okay, how many ways can I pick 2 black ones? 5, choose 2. Okay. And with each of those choices of the black ones, I need to choose some white ones, and that'll be 10, choose 2. And I need to choose some red ones, and that'll be 15, choose 2. Right. And this will be 30, choose 6. Okay, and there it is. And that's actually what that formula is saying. So the formula is horrific, but the actual answer is not too bad. Can someone get that for us? It's okay. So what I'm going to do at the end of this lesson is I'm going to do a very simple one, and I'm going to try and teach the understanding again, because I think this is actually quite easy to teach you how to do. Yeah. And so we'll come back and we'll try and pick the understanding up again. Okay. Has someone got an answer for this? 0.08. So guys, only about 8%. Okay, so not all that likely. Okay. And if you think about it, guys, if you think about the actually they're only 5 black beads or marbles. Okay. All right. Can you turn over to page 27 and try that one? Sorry? It doesn't matter. Yeah. No, I'm not fussed, guys. I'm not fussed about what format you gave your answer in. If the answer is right, in other words, if you've written 4 out of 25 or 0.16 or 16%, all of those are okay. All right. Okay, suppose I draw 4 cards from a pack. Okay, now you do need to know about packs of cards. Does anyone know how many cards there are on a pack? There are 52. How many of each suit? 13. So 13, 1, 13, 1, 13, 1, 13, 1. 1 club out of 13, 1 diamond out of 13, 1 heart out of 13, and 1 spade out of 13. Add up all the tops, add up all the bottoms, and on the bottom you've got your sample space. The number of ways you can choose 4 cards. Okay. All right. Can someone work this one out for me? Okay, so about 10.5%. Okay, and I'm not too concerned about the exact answer. Right. Okay. Right. Guys, remember you're welcome to ask me for help anytime as well. Okay. So like, I know one or two of you have said, no, you want to get help. And then I've said, well, send me a Teams message. And then I haven't had any Teams messages. Okay. I'm also aware that some of you have gone to other teachers for help. That's absolutely fine. Okay. But they're not actually too many other people can help.
So how many can actually?
So the Miss Moffat,
Out of seven.
Miss Moffat, Miss Smith, and myself, I think, are the ones that have taught this. Yeah, Mr. Grace says he'd work it out. He's never taught us. Yeah, super. This is true.
You're right.
I'm going to give you some time just to try the whole of question one, the whole of this exercise. Okay. And then what you were talking about.
Oh no, this is Chills. The 3 alien. Really one. That's what would be if you just prove it? You just made it prove. Sorry, sir.
Yeah.
What would be the difference if every time you pick the beat, you put it back in? It's
Totally different thing. It's a thing called binary. Shouldn't be acceptance. That's different thing.
where bar.
No, and you'll see why. Because the probabilities change.
Oh, yeah.
They don't change. Here the probabilities change. You know, you take out a green one, chances of another green one. It is. It actually is.
Why?
Guys, this year is a 5 to 10 lead.
Before we move on to that,
Yeah.
if this little formula,
Yes.
I don't know how much everyone else is understanding it, but my understanding is there.
Yeah, that little formula is underneath. The reason I've showed you that formula is because it appears on the data sheet.
But what is it for?
It tells you how this distribution works. Okay.
Oh, this is that how is it?
No, that's that particular form. And that's what I'm saying. In a way, it's not very helpful. It's just a context with only 2 color feeds. Okay, yeah. I'll come to that. One, 2, 3. What? What do you think of instead of and then I don't want any of these.
That's a good one.
It doesn't actually.
Doesn't change.
It doesn't change. I'm the bottom down.
Get already getting ready.
So it's 10.
Well, that's good.
So you got this, although this is important, it's very important to you now to and if you're applying this idea of degree and the problem, then you actually need it. Yeah. Because 10-3 is the good example. Now, the reason for this, and this is right. But when you get the one, think about going it up. There's actually different ways in which 1 red and 2 green can be green. You could get the 1 red and then the 2 greens. You could get a green and then a red and then a green. Or in fact, you could get the 2 greens and then the red. Yeah. This is nothing. This is just one of those. Okay. And that does the thing. Okay. And let's leave it as one. Yeah, the reason I'm right? Probably getting one with it. Now, this is now normal formats probability. What's the probability? Picture, yeah, picture, three lines. Yeah, three. That what's the probability of getting a red? First time, what's the probability of getting a red? Three out of three. Yeah. Then, what's this probability? This would obviously be
0.
You have to be two out of 10. And then whatever other countries, yeah, it would be 5 out. I'm not worried about equal functions. Okay. Now, I draw a red. Okay. Taking a red out. What probability did I now get the green? Okay, so this is now the green. And again, there's two options to get it. Now, if I can read out any one, okay, can someone multiply these together? We get 1/100, and that's the answer. Right. And the reason it's a third, the reason because there's two other branches. Listen carefully. There's two other branches. Green. You could it's not yellow. So you got the green first. Put in here a red and green, or a green and then. That's why this is actually one of the. Yeah.
Can you do questions with the choices like question about?
No.
One answer?
Because the order, because there's the way above is allowed for any orders. The way below is only, and then you could divide it by 3. Yes. You could get that top thing and divide it by 3. They can happen in 3.
So,
Watch.
You might feel the difference.
I think I'm going to stop.
What about the next green?
Watch.
Yeah, it's the might work.
Watch.
Yeah, might work, and I'm not 100% sure. Yeah, that's. I'm disagreeing. It can't make sense. That's so this is something, and now listen carefully here. You do that for me. Yeah. What? Yeah. How many beads am I drawing out here? 2. No. How many beads am I drawing out? No, 3. 3, guys. I removed 3 beads. Okay. Yeah, but okay, so got B, draw 3 beads, and I don't replace them. How many possibilities are there for the number of green beads that I can get? No, in fact, what are the? I think it's 0 or 1 or 2. Now the reason you can't get 3 is that there are only 2. So once you've taken 2 out, you can't get another one. Okay. Now watch this, only because this is the formula you get given on the formula sheet. And what it says is that if you want to get 2 green beads out of 2, then you need to get the balance of your beads. We're drawing out 3. What's the balance? No, that's going out to that is 3 minus 3. Yeah, and the top is the top. 8. You got that 8. 8 non-green beans. Yes? Yeah. On the bottom, add and the add and add is not going to choose 3 beans out of 50. Okay, does it make sense? Yeah. Now, you can help me make even more sense.
It makes sense.
What would be not going to happen? Okay, so the formula, guys, the formula, someone decided over the years for people who have done the formula. So they get the formula, but they, these are variables.
What does big green stand for? Big green.
Okay, big green stands for the probability of getting a number of green beans equal to little g. So big G stands for number of green beans.
And little g stands for?
Little g stands for actual values, the specific values of the container. Now, guys, what I want to quickly, just hang on 1 second, just what I want to quickly ask someone to do for me. Can someone work out this? Can you put 0 in here on your calculator? So I'm going to 2083 over 10.3. And can someone else work out the probability of 1 green? Okay, in other words, put 1 in where the 2 are. And lastly, can someone else put in 2 G's? Okay,
What's this?
this is 7 over 15. Okay, then put this one just with 1. So, 14 out of 50. Yeah. That's 1 pound. Impossible.
So why do you say 0 else? Okay, thank you.
Now, zero. 8 from the negative or the 10 from the yeah, let's say the negative. Yeah, now, you know that 1. 8 from the negative. 7. Now, yeah, now, 2 from the negative 2. 8 from the negative 1. Or the 10 from the negative 1. You got what you want. That add up to 1. Add up to. Zero. Now, okay, now to come to the question. Thanks, guys. Why do we say 0 elsewhere? Because greens or 4.5 greens or 7 1/4 greens, 0. Okay, so when you write down a probability distribution, this I write down the probability distribution, the number of yellow. The big one equals little one. Now, this is slightly different to the other one because I think you can actually get more yellow beads than you can get green beads. 5 yellow beads. Yes, yes, it's only drawing 3. Correct. I got 5 yellow beads. And in the first one, I want to choose 4. Okay. Now, if one of them going on 3, how many of them 1 yet? 3. Yeah. And how many non on the bottom, this is going to be 1, 2, 3. Now, What? Okay, because it's the balance of the beads. I'm drawing out three. So if one of them is yellow, how many are non-yellow? Two. If two of them are yellow, how many are non-yellow? One. And so it's the complement of three. Okay, which is why 3 minus. Yeah. And if you go and look at the formula, guys, I'm going to go back to the formula. Let's get that. Right. Guys, what values do I have? 0, 2, 4, 3. 0. So just look at this cloud. My pen is not going to catch up to me because the thing software is now slow. Yeah, 0 and also. Gents, listen. Remember that what a probability distribution is it's how the probabilities are distributed, shared across the outcomes. There are 4 outcomes. Would you like to write down, I mean, in an example, what you have to write down, y equals 0 is 1, 1, 1, problem, y is 1 is 1, 1, 1. So we don't do that. This is a shorthand. This is the formulaic way of writing down. Okay, right. I'm going to go back to that formula because it was stressing Ollie out amongst others. Okay. Yeah. So it's guys there. Now listen. Is what these things stand. Little a. Yes. Little a stands for the number of people. Big A stands for the total of the people in the top. Little R stands for the equal the number that you are people of that kind. That many beads of that. So for example, I want R main beads out of a total of P beads. Yes. Okay. The balance of all the N beads are non-beads. These are non-beads. And if I'm getting R green beads and I'm taking N beads out, then the balance must be non-bead. So the formula does make sense. But it's there. Okay, but it's I'm saying don't worry about the formula. I'm saying do the questions. Now, the next 2 questions come out of the last 2 years trials exams. Okay, so these are proper matric questions. I want you to try and do them. Okay.
There's this
Sorry. Yes, yeah, that's right. But that's the formula. It's not just it's a formula with the specific numbers for this case. Sorry. No. Yeah. Right. So guys, here's the thing. Formula, I get exactly 1 boy from each block. So this is and this is the thing with these can be beads in a the other ones. It's the same question. You agree? Yeah. No, this is like just one of the questions. It's not an easy one.
It's not than 3.
It's just one of it. It's not difficult. None of it's doing it. Actually, guys, the thing with AP maths is it's different maths. It's not harder. Often, you guys saw this last week. How many people better? The ticket. How many did better in AP last year with the exam than in 4? Yeah, loads.
and the year above us, so I'm going to better.
That's that.
That's not easy.
No. That's the. Yeah.
Well, exactly. I did it too.
No,
So we definitely. So
they're self-studying. So watch videos of each. That's something.
I get a big fat.
It's not about us. I need one and not. Now, guys, listen carefully to this, and try and understand why this thing works. If you were, if the Dixie Boys in McCall, okay, and I just want to choose any 5 of them. Well, how many ways can I do that? 60 to 5, 60 combination 5. You can just work that out. 75. 5, 460. 500. So that's the big number. Now, if there are 12 A blockers, and I want to choose one, how many different ways can I choose one A blocker from 12? It's 12 combination 1, it's obviously 12. Okay. I want one B blocker. 12 combination 1. Now let's just stop there. How many ways, listen carefully, how many ways can I choose one A blocker and one B blocker?
Combination.
One B. No. 100%. 12 combination 1 times 12 combination 1. You mean that I can choose any one of 12 blockers. And with any one of those 12, if you pick any one of 12, there you go. So how many combinations are there? 12. 144. And then everyone choose one to the five because he's a woman. So we can do the exam. Yes. Yeah. Yeah.
What?
That's the thing. Can't be very good. Okay, now listen carefully to this. This is the harder part of this question. 8 marks as opposed to 6. What's the pros that get more seniors than juniors? Now, I'm not worried about what blocks they're in. I just need to get more A and B blocks than juniors. Give me some options here.
5 and 0.
I could get 5, okay, and 0 juniors. I could get 4 seniors and 1 junior. Or I could get 3 seniors and 2 juniors. Those are the only options. Now I need to calculate these. And now, okay, don't worry about the blocks. Group the blocks together now. How many seniors are there?
24, you need 5.
Which means that I'm going to 0 from 36 junior. And this guy, this is going to be 50 to 5. And then we see if it comes around with a different company, we're now going to do 1 junior and 4 seniors. 4 seniors out of how many? 24. 1 junior out of how many? 36. Over 60. But, and then lastly, okay, 3 seniors and 2 juniors. 24 seniors, 3 of them. 2 juniors, and 6 and 65. And guys, we're going to definitely add these. As soon as you're talking about different cases, you're going to add. Okay. This is a way of thinking. Okay. It's a way of thinking, and it just takes a bit of getting one's head around. Yes. Has anyone got a final answer? 31. 31. Now, guys, this is the other thing, is that the timing in AP Maths is quite. So you have 8.5 minutes basically to do that. Yeah. If you know how to do it, it's actually very easy. If you've got to stop and think about it.
Check final. Stop.
So what?
Okay,
Like that, we get for this paper.
okay, right, guys, now this is the year before, right? This is the year before. And that's the other thing with that is if you will see, if you do some past papers, the questions are often quite similar. Okay. So we've already actually answered this question today. Four cards of gold in relation to 50 people. Okay. 130, 130, 30. Yeah, that's a good.
We've already looked at this. Oh.
We've done this. What's amazing? Other than that, they don't listen to other people's questions. They don't even often listen to what I'm saying. Yeah. Right. Can someone remind me what the answer is to
They failing. They failing.
about 10 and a half? Right. Get more red cards than black cards. So now we're not talking about suits anymore, but it's the same idea. We're just talking about colors. Okay. How many red cards? What different cases will give me more red cards than black cards? 4 reds and no black. Right? Or 3 red and 1. Okay. I can't get 2 of each because then I haven't got more reds than black. And I can't get 1 red and 3 blacks because then I've got 2 of each. Okay. Now these are 2 separate cases and you've got to work them out separately. Okay. Yeah, then you're gonna absolutely. Correct. 26 combination 4. 26 combination 4. 26 combination 0 on the bottom. Okay. This one, 26 combination. Oh, as these are not catching. 26 1. And interestingly, listen to this. What would be the probability that I get more black cards than red cards? Exactly the same, obviously. And then it's the same, what would be the answer? What would be the problem that I get exactly the same of each? 2 red. 40. Absolutely, yeah. Yeah. Because and see, because like there are only 3 things that can actually happen. You either get more reds and blacks, or more blacks and reds, or the same number of reds and blacks. Yeah. Blacks is that, or some reds is obviously going to be exactly the same. The same of each is going to be the same. Right, guys. On Monday, now guys, you'll notice we've got to the end of the section. On Monday and Tuesday at least. So that's 4 lessons. Okay, because on Monday we have 2 maths lessons. On Tuesday we have maths lesson and further studies maths lesson. Those 4 are all going to be dedicated entirely to core maths.
Yeah, we'll be back doing it prep.
We've been doing it prep. Yeah, but we'll carry on with it. I'm hoping, guys, I'm hoping you'll be doing so. Some people don't think they've done any. That's why I don't want anybody to be kind of left behind. If you've got some time this weekend, quadratic equations. They're easy, guys. They really are easy. Okay. Have a wonderful weekend. Thanks, guys.